Hello guys, good evening. Today I want to share to you about PID design to control radiator fan speed of vehicle. This topic is an alternative approach to control radiator fan speed of vehicle using uh, fuzzy logic. Okay, what is a PID controller? It is a special type of controller with proportional, integral, and derivative. It is something like parameters and constant. It is term acting on the error signal. The figure below shows the model in Simulink, which consists of step, model, sum, and this PID controller, and the process model is the transfer function of the system. So this represents the radiator fan speed, and the planned output is the scope that we can build in the Simulink model. Okay, why PID controllers are everywhere? More than 90% of all controllers used in process industries are PID controllers. A typical chemical plant has 100 or more PID controllers. PID controllers are widely used in chemical plants, oil refineries, pharmaceutical industries, food industries, paper mills, electronics, equipment, etc. So, how to control radiator fan speed of vehicle using PID controller? This figure shows the radiator fan speed with encoder and the Arduino and the driver. So the fan speed is controlled using pulse width modulation technique using a program in Arduino. Okay, the next step is we need to think the design consideration. This is the example. In normal temperature 30 degrees Celsius, then the normal fan speed is 100 RPM. In case of the change temperature, the fan speed has a formula like this, that RPM instant plus minus 2 times delta T degrees Celsius. This means every delta T temperature increase, the fan speed increase to 100 RPM plus 2 times delta T degrees Celsius. For example, if delta T 2 degrees Celsius increase, then the fan speed equal to 104 RPM. If the initial RPM equal to 140 RPM and the delta T decrease to 2 degrees Celsius, then the fan speed decreased to 136 RPMs. The transfer function is obtained from system identification of MATLAB using the data logging that has been obtained from Arduino. So this is the program in Arduino. This shows a sampling data program of PID to obtain the transfer function. I will show to you the program in Arduino like this. Okay. Next, this is the Excel data from Arduino program. We can copy and paste to the Excel. This is the result from Arduino program. And after that, we go to the MATLAB and we need the program to enter data from Excel to MATLAB. Then the input and output need to be identified. Run the program using system identification at MATLAB to obtain the transfer function. Alright, let's demonstrate. So this is the program, and first we need to type data equal like this, enter, and then we double click in workspace data. Okay, now we copy and paste this data in Excel to this place. Okay, already copy, and now we go to the editor, and then we click run. Now we get the sampling time 0.026, and next we click apps and click system identification to get the transfer function. Okay, now we choose time domain data, and the input is X, the output is Y, and the starting time 0. Now the sample time is the sampling time we obtained from this program 0.026, and then we click import. Okay, the data can be drag and drop to the working data, and then we choose transfer function in estimate, and the number pulls to number of 0, we type 0 and then click estimate. Okay, the result, we get the result and close again. This transfer function drag and drop to workspace, and the MATLAB want to save, overwrite, yes, before already. Okay, now we can close and save. Okay, after that we type the F1 here, enter, and we get the transfer function. This is the transfer function. Okay guys, now we go back to the presentation. After we get the transfer function, we can build the Simulink model like this. We open the Simulink and the library, so we type steps, something like this, and then enter the step to this workspace. Okay, it's easy, and we connect this and we enter the transfer function as shown in the result here, 2744, like this, and 1 space with 53.5 like this. Okay, click, and then we can double click PID and click tune. We get the plot. Wait a minute. Okay, this is the plot, and we can show the parameters P, I, and D like this, the value, the parameter and the constant, and we can change this parameter using this tool like this. We can make it close to 1. Yes, this is better. Just wait a minute. Better. Okay, and then update. So this is the new PID parameters that we can enter to the program, the Arduino program to control the radiator fan speed. Okay, now we go to the model, and now we double click the scope and then run to see the comparison regarding the scope and the step, and the step is the blue color and the yellow color is the transfer function that we obtain and we tune. Okay, the system is closed to the desired value. Now I will show to you the Arduino, the program we find. Alright, this is the KP, KI and KD. We enter here this program so that we can run the radiator fan speed using the PID controller. Okay, the conclusion is that PID controller demonstrates can control radiator fan speed of vehicle. Thanks for watching.